In this recording, we're going to review Green Book Assignment number 4, Probability and Statistics and Sequences in Series. If you're using the companion packet, look at session number 6 at the end of the packet. The first question involves a binomial expansion. Well, there's 3 components to the binomial expansion, to that term, the fourth term. There's the coefficient, which we're going to get from the C notation. There's the amount of x's, and there's the amount of y's. Okay, so first off, we're going to get the C notation. Because we start counting from 0, the fourth term has an R value here of 1 less than 4. It's 3. Okay, because we're starting from 0. So it's 0, 1, 2, 3. The fourth term has a 3. And of course it's 5 here for every one of these terms because 5 is the overall exponent. Next we need the two x's and the negative y. Okay, so we get the 2x and the negative y. Now I've done this in purple here. Because we're starting negative y's exponents also at 0, this 3 and this 3 correspond. They're always going to be the same here. And then the number here, the exponent for the 2x, well, the exponents have to add up to 5, so it's just a matter of 3 plus what equals 5. In our next stage, we're going to do some simplifying. We're going to go to the calculator and figure out 5c3, which is 10. You can also get this number from your Pascal's triangle if you prefer. I distribute the exponents to each factor inside parentheses, so 4x squared and then negative y cubed. Now it's just a matter of multiplying the numbers, the negative 1 times the 4 times the 10, so we get negative 40 x squared y cubed. This problem involves the normal distribution. As you read through the question, it never mentions explicitly normally distributed. However, because it's a national exam, we can make the assumption that there's going to be a normal distribution here. There's enough data, and the data are going to be distributed according to the probabilities in the bell curve. So let's start it out the way we always do. Let's make a layout here where we've got mean in the middle. We're going to go out 1 standard deviation in both directions. I'd like you to put your labels on your bell curve like this. Next, underneath each one of these, I'd like you to put in a number and then play the recording. So hopefully you put underneath 428 is the mean, and then we go up by 113 and down by 113, which is the standard deviation. Now we're ready to start answering the question. Well, the question says approximately what percent is between 315 and 541. Those are numbers on our layout here. So we're interested specifically in shading in this area between 315 and 541, and they turn out to be -1 standard deviation and +1 standard deviation above the mean. Now it's time to go to the bell curve. So we look at our bell curve between 1 standard deviation above, 1 standard deviation below. We take all those percents in between, add them all up, works out to be 68.2. Next question is a Bernoulli probability. Okay? Wants to know what's the probability of landing in an even numbered region. So it's a Bernoulli because it's a 2 outcome probability. It's either even or odd. This question is complicated by the fact that it says at most 2 times out of 5. Well, first off, we have to find the probability of any such spin landing in an even numbered region. So hopefully you can see that the probability of it landing in an even region is 1 out of 3, and the probability of it being in an odd is 2 out of 3. Let's proceed. Now we need to figure out what at most 2 means. And you would think that would be obvious, but often students will leave out a critical number. They'll leave out 0. If we're talking about at most, we're talking about exactly 2, exactly 1, or exactly 0 even spins. So we need to do 3 separate calculations and add them up. So in the first calculation, it's going to be a 5c2 because we have 5 spins. I want 2 evens. We have the probability of even and the probability of odd. The exponents correspond to the number of evens. So I want 2 evens. That must mean there are 3 left over to be odd. In the next calculation, it's a 5c1. Still 5 spins, but I want one of them to be even. Therefore, the exponent on the 1/3 probability, remember, even was 1/3. So one of those, that leaves 4 of them to be not even. Finally, if I want exactly 0 even, I've got a 5c 0. That means the exponent of even, which is 1/3, is 0. The exponent of odd is 5. Now it's just a matter of work out each one of those separate probabilities, add them up. I'm going to leave them as fractions here because they never said what to round to. So if I add up all those and in simplest form combine them, works out to be 64 over 81. In general, it's a good idea to leave it as a fraction, even if you use math enter, if it doesn't specify the degree of decimal places to which to round your answer. Okay, this is a standard deviation question. We're going to need our calculator to find the standard deviation of these scores to the nearest tenth. Let's go to our calculator, let's hit Stat, Edit, and let's clear out anything that's in there. So we hit Clear, Enter, one around the heading. Okay, so I'm completely cleared out. In L1, I'm going to enter the data set. 38, 38, 43, 45, 46, and 48. Now I'm going to do Stat, Calc, one of our stats. My list is in L1. I do not have a frequency list. So I'm going to hit Clear, and then I'm going to go down to Calculate. Okay, an important number here, n equals 6. Yes, there were 6 data points that I entered. The mean is 43. The standard deviation of the population is 3.8, rounded to the nearest tenth. We'll only use the standard deviation of the sample, Sx, if it explicitly says this is a sample in this course. So we've got the first part of the question answered. Find the standard deviation to the nearest tenth. Second part is, how many scores are within one standard deviation of the mean? So just like in the normal curve question, we're going to do a layout, but there's no normal curve here, so don't draw the bell curve. Just make a layout like this. One standard deviation to the right of the mean, one to the left. Put your mean in the middle, and then add 3.8 and subtract 3.8 to get the values that are one above and one below the mean. Now let's just do some counting. The only scores that I see that are between 39.2 and 46.8 are the 43, 45, and 46. So scores that are in the interval are those. The answer is 3 scores. Okay, I'm going to give you a couple challenging sequence questions here that involve recursive sequences. A recursive sequence means the next term is always based upon the previous one. So it's difficult to jump to like the 50th term because you have to find all 49 terms that preceded it. So we're not going to ask to find 50 terms, we're just going to ask to find 4 here. I find this can be made simpler if we make a chart and are really organized. So my chart is going to organize the value of n, which I'm color coding with red. And then this is a sub n, the value of the term. So this is which term? 1, 2, 3, 4. This is the value of the term. And it has to give us a starting point. So it tells us explicitly the first term is -3. And it gives you a way to find the next term. So the next term, it says, you want a sub 2? Okay. Well, you have to take a sub 2 minus 1, which of course is a sub 1. And then it says take away n. Well, over here n is 2. So we got a sub 1 minus 2. Well, I know the value of a sub 1. It's -3, so it's just -3 minus 2. Of course, that's -5. Next term. You want to find a sub 3? Alright. Well, the formula says you need to take a sub 3 minus 1, which means a sub 2, the term before it. Then you need to subtract n. So when we subtract n is 3 here in red. So it's -5 minus 3 comes out -8. Last term, a sub 4. Right, according to our formula, you want to find a sub 4? Well, you have to take a sub 4 minus 1, which is the same thing as saying a sub 3, subtract 4, which is the n value. Of course, a sub 3, we just figured out, it's negative 8, so it's negative 8 minus 4 equals negative 12. We've got our 4 terms in the recursive sequence. This next recursive sequence is geometric because we're multiplying by 3/2. So I'm going to do a similar layout. We've got n in a color. The first term is given to us 64. Now to find the next term, that's where n equals 2. A sub 2, well, it says you're going to take a sub 2 minus 1, the term that came before, basically, and multiply by 3/2. So we're going to take the 64, multiply by 3/2, it's 96. Okay, and the next one, a sub 3, it's saying take the term that came before, a sub 2, multiply by 3/2, and of course that's 96 times 3/2, it's 144. That continues in that pattern. This one's a little simpler, just saying take the one that came before each time. So a sub 4 wants to take a sub 3, multiply that by 3/2. So that's 144 times 3/2, you get 216. Last one, in a similar way, you're going to multiply your 216 by 3/2, you're going to get 324. The last question involves a regression. So we're going to do a logarithmic regression on this data. So first off, I'd like you to get that data into your calculator, and then play the recording when you're ready. Okay, so we've got this data entered into the calculator. Now we need to do the logarithmic regression. So we're going to go to Stat, go to Calc. You're going to notice lots of options that end in REG, the regressions. There's a linear, quadratic. This is the one we want, choice 9. Natural log. Okay? Do not choose choice B, logistic. We will never use that in this course. The only logarithmic regression you have is ln, natural log. So choose that. Make sure there's no frequency list. Our data is in L1 and L2. Frequency list should be cleared. Go down to calculate, and you should end up with this information. Okay? Next, we can now write our logarithmic equation with our values rounded to the 10,000th. That means 4 decimal places. Okay, we should put on our paper what work we did to get that equation. That was sort of the not do thinking part of it. Now we have to do some thinking. Okay, part B asks us to find the wind chill value. That's in a y value. When the wind speed, that's the x value, is 50 miles an hour. So if you can sort of extrapolate on this chart, that means go beyond the data set. 50 is down here. I'm seeing that these are decreasing. I'm expecting a number that's negative beyond negative 12. So fortunately, this is a pretty easy problem. Let's just sub in 50 for x. Let your calculator do the work. Negative 16 degrees Fahrenheit. And we thought it would be somewhere around there. The third part of the question is more challenging. It says, based on your equation, if the wind chill factor is 0, okay, so that's giving us a 0 here, what's the wind speed? So that would be putting a 0 in here. So somewhere in here, I'm anticipating a number, I don't know, somewhere between 5 and 12, maybe around 6 or so, 6 or 7. Okay. So we're subbing in 0 for y, we need to solve for x. So it's a natural log. So the first thing we want to do is get the natural log by itself. Get the 13, negative 13 over to the other side, do some division, and that means the natural log is equal to 1.77, etc. When you're stuck with logs, put it in exponential form. So this is equivalent to log base e of x. That's what a natural log is. So now I've got a base of e. Log is an exponent, so raise that to the exponent of 1.77, etc. Put that in your calculator. You've got your value. And we thought it would be around 6. That makes sense. Thanks for watching.